collectors and tuning. Collector configuration. This is where you would identify the collectors. Now you've already been set up for CO2, N2 and hydrogen. So collector assignments. So you have cup 1 and 5 for hydrogen, 2, 3, 4 for nitrogen, 2, 3, 4 for CO2 and 2, 3, 4 for CO.
Right.
Peak sensor settings. So when it does peak sensor, sometimes if this is too wide, what can happen is it starts taking in other peaks and it gets confused and starts like, oh, I can't find the peak, even though you can see it. So the peak might be here, but you might have a bigger peak that's kind of coming down, and sometimes if that happens, it can get like a little confused. So this is a.
So that's the window, right? For peak center.
Yeah.
I saw that often with a high peak this size.
Yeah.
What cause that? Because you have too wide.
It's the window's too wide, so you're actually looking at the other peak coming into the. So as the 45 goes across, and then 44 will come in, and it's like too big. 44 is more intense.
Can I see the 44?
So.
Okay.
So what's happened is when it's sweeping, so you got 3 beams sweeping like this.
Yeah.
And ideally you got like
44, 45, 46.
Actually it's the other way around. So 46, 44, 45. It's the wrong way around. So the lighter cup is the one that's furthest away. It's greater deflection. So this is actually mirror image.
So,
but if you imagine that the beams are going like this, so it would be going, all right, so that's 45 goes across, and then the 44 starts to come into the cup.
Yeah.
Which is more
so
intense.
Because we are looking at the middle cup, and middle cup is assigned for 45.
Yeah.
And when the 44 comes through, 44 is more common.
Yeah.
CO2.
So it's more intense.
It's a carbon 12 and oxygen 16.
Yeah.
And plus this high resistance, you got that high peak signal.
Yeah.
Got it. Yeah.
Okay, so this is we've got it's I'm in CO2 at the moment, but you can actually go and check each of these.
So all these are already set up.
Oh, it's already set up. You probably never need to do this. Now, sometimes you might want to, if you're interested in this, you might want to change the resistance so you get a more intense signal. Excuse me. Oh, okay. So
we already don't change the resistance.
no, you shouldn't. I'm telling you where it is, in case you need to, and it's also in the manual. But in reality, it's like, you don't need to touch that. Okay. All right, tune books. I talked about it, but I'll talk about it again. So tuning. Okay, so these are the ones that you have set. You might want to create some of these. These are like default, but usually these are factory set tune books. But these are the ones that these are the common ones that you would use. So you can just bring these up, and then you'd have to tune it and optimize it and things like that. But these are the ones that you'd use.
CO2.
And this is one that's active. Session history, we talked about. Cup configurations is there. Autofocus, manual focus, peak shape, linearity correction. You don't have a linearity correction for CO2. You do have it for, so this is where you do your H3 factor. You do it, let's go into this. So activate. Okay, so I'm now activating this. So you now have hydrogen in there. So this is your linearity So one of the specifications we have is to do the so many over an hour,
Right.
and it's got to be, you know,
It's
it's got to be stable. But anything less than 8 is great, and so you know it'll work. So if you click on this, press this, and then you start it.
and the because we do H3 factor every day, this will be saved in the session history, or on in
Yeah,
the
yeah,
linear-
it'll be saved here.
or save the linearity.
But the other thing you would do as well is in the lab book. Let's find.
Oh, okay. It's there. HD linearity,
It's,
the bottom one.
yeah, no. So the HD linearity is to see that it's actually worked. So I'll show you what I did for that. But okay, so this is. Okay, so what you can do is set this up so it'll do a H3 factor initially, and then every 10 samples it'll do a new H3 factor.
Okay. So that's for GC, Isolink, HD, MK. Okay.
And conditioning, you can have that on. Right, I need to.
What does this conditioning mean? Is it
The-
long or short?
Right, so I'm gonna have to create a new one from scratch because. Yeah, okay, so HD. Oh no, I can't do it in here. That's what. This right. So cancel. Yeah, I can't create it in here because it's not. This is a mistake I was just talking about. So let's come out of this. Let's go into here. Bing, 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 bing. What's going on? Okay. All right. So empty. And then trace. Okay. So let's do. No, we don't want that one. We want this one. Okay. Right. Lab book. So I'm doing this without it's that's like 2 or 2 3. No, it's not 03. It's 4. 01. 03. All right. Okay. So I want the H3 factor on.
Tune book is changed.
Yeah.
Tune book is still true.
All right. Yeah, it defaults to CO2, so I have to change it. But that was a good spot. But I discovered that it's a GCI thing. What's happened? There's going to be a short condition. Wait. Right. Oh. One moment. Let me. conditioning. Okay, so HTC oven, you can do these small
That's right.
yeah, conditioning time, 30 minutes backwards. I don't think you need to condition for hydrogen because you've got the gas, let me think here now.
Yeah, I don't
You don't need to condition. It's only for the HCC. I don't think you need to condition for. It's all you need. If you look at hydrogen, it's just you're just gonna pyrolyze it, so you don't need to condition it.
On the CO2, you need a seed oxidation or
Yeah,
long oxidation.
yeah, seed oxidation or long oxidation. The other thing as well is for the CO, you should have enough residue from the solvent front
Right.
on that combustion
The reactor.
to feed it, so you don't need it. So you don't need a conditioning on the HTC side of things. You only need it on the combustion
The
side.
combustion. Yes.
So, okay, so you don't want that. I've got to try and remember this now. So I need that to be in seconds. So first thing first is you want the back flush on.
Okay.
So 1 second, back flush on. Then you want the references, 15 seconds. I don't know, that's a target intensity, about 3.
Right.
Might even be less.
Yeah.
Number of pulses, 3. You might want more. So you pull this in again, back flush off, normally about 450 seconds, and then back flush back on, around about 1350.
We can set you're setting our lab book for the hydrogen now, right?
Yeah.
Maybe we can set up for a standard sample now.
Okay,
no,
okay.
okay.
So what I was talking about was the H3 factor for hydrogen. That's why you set it up here. So that's what I was trying to show you.
Right. Okay, let's do this. Sorry.
Yeah, no, it's fine.
Let's start with the simple version.
Okay. So so then we do 1400 seconds. So that's setting up your parameters. It's relatively straightforward, and I think you talked to that point. You say, yeah, it's a lot.
When I was doing it, it felt,
A lot quicker, yeah.
For sure.
Especially when you get into the rhythm, it's like, okay. So, and then the peak detection, they're there again. Compound editor, I don't really bother with that, but I think if you wanted to put your GC compounds in that,
Yeah, we can edit them later.
Yeah. Okay, so I'm looking at hydrogen 0, import, and then, so I need to add hydrogen, H2 0, and I want the second and third peaks. I
Right.
don't normally do the first peak because sometimes there's a bit of a wobble on it, so I'll let that go through, and then the second and third peaks I take the average of. Right. So you look for 20 minutes. I've got to try and. So it's PTV valve, create new method. So I want 1 microliter. So this is where, if it's not going to be in the sample list, this is where you create the method.
Right.
Yeah.
We usually vary the injection volume because we don't want to run sample at the same concentration. Because for the same sample, we run 2 replicates, right?
Yeah.
Maybe one micron, or the other one 2 micron, or maybe one is 1.5, and the other one
But
is
so
2.
because you don't know, and you want to pick the one that's out of the data that's correct.
We want to calculate the standard error
Okay.
using 2 different concentrations.
Okay.
Yeah.
Then I'll need to go back and change.
I'll check that one,
Yeah.
right?
I need to check it.
Oh, right. And,
Okay.
and that's from the
The configurator.
Okay.
Yeah. Okay, so I'll need to go back and check that. Okay, so I don't really.
So the PTV you created on the Chrome.
Yes.
Okay.
So I want to wash that pre-injection once. I want to go back to A and do 3 post-injections. Yeah, we'll do 1 rinse. This is all standard stuff. Next, yep. Constant flow, yep, looking at 1.2. I think these are all standard parameters here. Split those. Okay, next. Alright, so now we've got ramp GC, so we're at 80 for 1 minute. New 50 to 290. That's going to be 5 minutes. Oop. Yep, okay. Next, you don't want to, I deselect that, you don't validate the column configuration, because once a column's in there, it's fine. Create your new method, so HD alkanes, finish. Okay, and check the method. Okay, alright, so it's found assignment for stop purge 4, but it's switched off. Okay. So that's just to help you. I've done it with both of those and it doesn't really make any difference, but you have this check method just to make sure everything's okay. And save that. Okay. And then you create your sample list, so file 1. HD. So that's it, and that's how you create your method, your lab book. Is that? Do you want me to, does anybody want me to go over anything?
Wanna try? No. Anything? I think it's good, right?
Yeah, you got you will play around with it when you get familiar. Okay, maybe just increase the temperature on the inlet, maybe reduce the wrap rate. You will do your own thing if you want to get better separation. You'll find what will work for you, and I can't teach you that. You've got to figure that out. What works for your samples, your analyses.
Is vial the position?
Yeah. So vial 1. 1, 2, 3.
Okay, what if we want to go to tray 2?
I think it's 55.
Oh, you just keep going on.
I think so.